G'day. Welcome to exterior, should I say, the next topic that we're doing, which is geometry, which is geometry of shapes, namely triangles, quadrilaterals, and polygons. Now, for you guys already in this class, you're already probably quite familiar with a lot of these rules. So I'm just going to give you a crash course reminder of what are all the triangle rules that we need to deal with. And the most common one is this one here, which is the sum of the angles of a triangle. Now, the interesting thing that we're doing here, that we're going to start now, is we need to explain what we do as we go along. And so, unfortunately, if you use a rule, at the end of that line of working out, you need to write sum of the angles of a triangle, and you also would do quite well from drawing the little picture. Now, that little picture isn't super important, but it's just a little habit that I've got myself into, and it's just basically explaining what you do in a shorthand. I also cheat, I need to be honest, and actually write sum of angles in a triangle. Now, that's a bit dodgy, but it's what I do. It's what I've been doing, and for the moment it'll do. So this is some of the angles of a triangle. So all of these add up to 180 degrees. Every triangle on the planet, doesn't matter what it looks like, will add up to 180 degrees. Whereas this one here is the exterior angle of a triangle. And that's saying that in this case, A plus B equals D. In other words, these two angles added up equal this one. This should all be revision. Okay, exterior angle of a triangle. The symbol of this one, obviously, is coming like that. And then we move up to the ones that we usually forget. What type of triangle is this? This is an isosceles triangle. And an isosceles triangle is this because it has two sides that are equal and as a consequence, two angles that are equal. This triangle, and the symbol is obviously that, or that. And down here we've got Old Faithful, an equilateral triangle where all angles are equal and all sides are equal. And all angles will have to be, if they're equal, 180 divided by 3 is 60 degrees. And so equilateral or, well actually, yeah, has to be that one. Okay, and so then we move down to a right angle triangle, which is this one here. And we know a right triangle when we see one because of the right angle. So, what sort of questions will we be required to do in this topic? Basically, any combination whatsoever of each of these. And so I've just stolen two easy ones. Here we have an exterior angle of a triangle, but what's different? It's that plus that equals that. They don't give us that one. We have to find that one. And so, what do we do here? So we know that 50 degrees plus K equals 110 degrees. And therefore, K degrees equals 110 minus 50, which equals 60 degrees. And this is the new bit that we actually haven't done before. Now we have to use our proof. We have to explain why we know this, and this is because of the exterior angle of a triangle. Lovely. So that's this one done. Nice and easy. Let's move down to the next one. Now this one's a little bit cheekier. Often you have to use some other geometry rules that you know. For example, the supplementary angles and so forth. In this case, find the size of the marked angle BDF. So that's angle B. Remember, D is the middle one, is the middle where the vertex is, and F, so it's BDF. We're looking for this one here. So if we're finding the exterior angle here, we know that that angle plus that angle equals that angle. But, so really, this is what does people's heads in with regards to geometry. You have to kind of go back and back and back and piece it all together like a puzzle. I know that angle is that angle plus that angle, and so I have to find it. How do I do it? Well, do you guys remember back in the day, our vertically opposite angles? Vertically opposite angles are equal. So this has to be 75 degrees, and therefore this one has to be 55 degrees plus 75 degrees, because that plus that equals that. But how would I write it? Well, I would write first line, angle CBD equals 75 degrees. How do I know it? Because of vertically opposite. Vertically opposite angles would be 75 degrees. The next, and from that, then I can say angle BDF equals 75 degrees plus 55 degrees, which equals 130 degrees. And I know this because of exterior angle of a triangle. Oops, I didn't put in my little symbols, I just put them in. These aren't certain, they're not always a requirement, but they're handy to put in. It's easy to mark. And we're done. So these are two examples of what we're going to be doing. But remember with these, you need to be able to, one, track back, and two, remember all of the rules. If you don't know the rules, then you're never going to be able to do these. I believe in you.